Welcome to today's lesson, folks, which is on density. Density is connected to mass and volume. We're going to see how it's connected to those two quantities, and we're going to be rearranging those two quantities to solve some problems. So let's crack on and get the job done. Density is a measure of how heavy something is in relation to its volume. In everyday use, we pick something up, and if it doesn't look very big or heavy, but feels heavy, then we would say, oh, that feels dense. If two objects have the same volume, but one is heavier than the other, then we would say the heavier object is more dense. In this example, two trophies exactly the same size, exactly the same shape, exactly the same volume. One is heavier than the other, so the gold trophy, being heavier, must be more dense than the silver trophy. And by definition, density is the mass per unit of volume and is measured by the mass of an object divided by its volume. So then, which is heavier, a ton of bricks or a ton of feathers? Well, the mass of a ton of bricks and a ton of feathers is exactly the same. It's just that the volume for your ton of feathers will be much greater than the volume for your ton of bricks. And that's because bricks are much more dense than feathers. They are heavier per unit of volume. In example 1, we have the volume of each of these trophies and we have their mass in grams. So what is the density of gold and silver? Well, for gold, the density, mass divided by volume, remember, would be 580 divided by 30, and that's 19.3 grams per cubic centimetre. And note the units, the mass is given in grams, the volume was given in cubic centimetres, so the units of density are grams per cubic centimetre. For silver, again, density, mass divided by volume, 315 divided by 30, and then that's 10.5 grams per cubic centimetre. Osmium is the densest element, and you may have some in a fountain pen nib. A volume of 350 cubic centimetres has a mass of 7.9 kilograms. So how dense is osmium? Density is mass divided by volume. So that's 7.9 kilograms divided by 350 cubic centimetres, and that's 0.0226 kilograms per cubic centimetres. They're the units at the moment because of kilograms was the mass and cubic centimetres was the volume. But seeing as 1 kilogram is 1,000 grams, we can write that as 22.6 grams per cubic centimetre of volume. In example 3, we're trying to find the density of a brick. Well, given that density is mass divided by volume, the first thing we need is the volume. Well, assuming it's a cube shape or cuboid, then the volume would be 20 times 7.5 times 5, and that's 750 cubic centimetres. Now we can use density, it's mass divided by volume, so that's 1,500 grams. No, I've changed the units, 1.5 kilograms, 1,500 grams. It's a more sensible unit to use, and that gives us 2 grams per cubic centimetre. We have density equals mass divided by volume, but what if you wanted to find the mass of an object? Well, we can rearrange the formula to find the mass. If we multiply both sides by volume, we end up with mass equals density times volume, and that's exactly what we're going to be using in the next example. In a previous example, we found the density of gold to be 19.3 grams per cubic centimetre. That means for every cubic centimetre of volume, gold has a mass of 19.3 grams. Well, in this example, the gold trophy has a volume of 50 cubic centimetres. So that should intuitively mean that would be 50 lots of 19.3. So mass is density, 19.3, times volume, which is 50. We check that the units are consistent. The volume is given to us in cubic centimetres. The density was given in grams per cubic centimetre. So the units are consistent. So we can just multiply the two values together. And we end up with a value of 965 grams. We can rearrange density equals mass divided by volume if we wish to find the volume. If we multiply both sides by volume, we end up with density times volume equals mass. And then if we divide both sides by density, we end up with volume equals mass divided by density. And that's what we're going to use in the next example. And in this example, we have 750 kilograms of osmium, and we know its density because we worked that out in a previous example, 22.6 grams per cubic centimetre. So what is the volume of osmium that we have? Well, volume equals mass divided by density. However, we need to check those units because our container has a mass of 750 kilograms, but our density is given to us in grams. They're not consistent units, so we need to do something about that. We change the 750 kilograms into grams by multiplying by 1,000. And then 750,000 divided by 22.6 grams per cubic centimetre gives us 33,200 cubic centimetres. You may find it more helpful to use the mass, density, volume triangle. Each of these letters here, M stands for mass, D stands for density, V stands for volume. How would you use a triangle? Well, in this example, we're trying to find the density. So we've put our finger over the D for density, and we are left with M divided by V, mass divided by volume. Therefore, we simply substitute our values in, and we end up with 5, and our units are kilograms per cubic metre. It's the units of each of the two measures that we substituted in, kilograms for mass, cubic metres for volume, that determine our units for the density. Here in example B, we're trying to find the mass. That would be M. So we put our finger over M, and we are left with D next to V. Now in math, two letters next to each other would mean multiply those together. So it's density times volume. Mass is density times volume. Substitute our values in. Now we must check that the values are consistent. Grams per cubic centimetre and cubic centimetre, the units are consistent, so we can just multiply them together. And when we do multiply them together, we end up with 150 grams, and it's grams because our units of density were grams per cubic centimetre. And in our final example, where we are trying to find the volume, we will put our finger over the V, and we're left with volume is M over D, so that's mass divided by density. When we come to substitute our values in, we must check to see the units are consistent, and note they are not. We have kilograms for mass and grams per cubic centimetre for our density. Consequently, we need to change these kilograms into grams to make the units consistent, and 4 kilograms is 4,000 grams. Now we can carry out the division, and that's 200 cubic centimetres. I hope you've understood the interaction between density, mass and volume and how we can rearrange them depending on what we are trying to find. Make sure your units are consistent, that is really important, and use the mass density volume triangle if you find it helpful. And if you've understood everything we've done in the lesson, then you've got the job done.